Okay. Good.
Okay, good afternoon and welcome to this fall 2009 Nokia Distinguished Lectures on Cyber Physical Systems, which is this year organized under the umbrella of CITRIS, the Center for Information Technology and Research in the Interest of Society, and CCIT, the California Center for Innovative Transportation. My name is Alex Bayen. I'm an assistant professor in systems engineering over in the CE department at Berkeley. This lecture is currently organized under the Intelligent Infrastructure Cluster at CITRIS, which is one of the few clusters that is going to be in the new CITRIS building. And I want to say this lecture is currently being broadcasted live to the other CITRIS campuses, in particular Davis, Merced, and Santa Cruz. And it will be later available for visualization on YouTube after the talk. And for those of you who are watching remotely, you can send us your question through IM. There will be someone typing the question. I will read them at the end of the talk, and that way the speaker will be able to answer the questions. So as indicated by the talk of and the title of the lectures, basically this lecture series focuses on the application of novel technologies to systems which integrate both physical processes and computation. And in fact, a good illustration for this is the Nokia Berkeley Mobile Millennium Project, which is a project which assembles cell phone technology to monitor highway traffic. And if you want to find more about this, you can look at our website, traffic.berkeley.edu, where you will also find the program of the upcoming lecture series. So we have a full set of lecture series this semester, which will have Richard Murray from Caltech, Manfred Morari from ETH Zurich, George Papas from UPenn, Bill Spencer from UAUC, Jerry Marsden from Caltech, Naomi Leonard from Princeton, and Eric Ferron from Georgia Tech. So the next talk will be on September 11th. It will be Richard Murray, same time, and his title will be Networked of Control of Networked Systems. So today's talk was announced as Dr. Iannucci's talk, and I would like to apologize for having to change the speaker in the last minute. We had hoped until a couple of hours ago that Bob would be able to join us, but the request of the California Superior Court, it turns out that Bob has to be on jury duty, so he will be serving jury duty for the California Superior Court today. However, Bob will be on campus on October 23rd for the launch of the Mobile Millennium in a press event that will be jointly held by CITRIS, CCIT, the California Department of Transportation, Nokia, and NAVTech. And again, more about this can be found on traffic.berkeley.edu. So we did not have time to re-advertise the talk. However, we had just enough time to manage Henry Thierry to fly from Finland to cover in case Bob would be called to jury duty. And so it's really with great pleasure and gratitude that I would like to welcome Henry today for this talk. The title of the talk will be the same, and let me just give a couple intro words about Henry. So Professor Henry Thierry is a research fellow at Nokia and currently the head of Nokia Research Center Systems Research. He's a professor of computer science at University of Helsinki and Helsinki University of Technology, where so he received a BS, MS, and PhD in computer science at University of Helsinki and has served on numerous panels, program committees, networks of excellence, and given a lot of keynotes and plenary talks. At Nokia, he is currently responsible for the research at the NRC Systems Research Laboratories worldwide. And in fact, the title of the talk today will be We're Just Getting Started, the Mobile Revolution Yet to Come. So please join me in welcoming Professor Henry Thierry.
Thank you. Half an hour, 40 minutes length of the talk. Half an hour, 40 minutes. Okay, half an hour. Okay, good. It's always good to give the professor the time, otherwise. So, okay, good. That's okay. Yes, okay, it sounds much more, how to say, extreme than it is that I flew from Finland. That is true. I actually flew from Finland day early. I live in Palo Alto. I was in Finland for a meeting, and I was supposed to fly this morning, so I would be here in the late afternoon. So as opposed to that, I flew yesterday. So let's not make too big of a deal of it. For me, this is a great pleasure to be at Berkeley again. I guess I finished my sort of affiliation with Berkeley 2004. So I was here 2 years with, at that time, the School of Information and Management Systems, working together then with some people. And on my previous Nokia life, I mean, before the time in Nokia. So it's nice to be here at the campus. Somehow the spirits of 880 traffic usually hinder me coming here too frequently. It seems to be that the traffic services are really needed.
Or we need a Nokia lab in Berkeley.
Well, yes, that's another alternative. Yes, really so. So one part of my role that I might clarify is that in Nokia we divide the research into 2 different clusters of labs. The other one is core technology and the other one is systems research. So I'm heading the labs of systems research, and my labs are then, well, everything is outside of Finland actually. And most of the core technology research is in Finland, or nowadays they just opened a lab in Lausanne in Switzerland. So my labs then are focusing more on the driving new business and innovation for new business of Nokia. So, and they range from Beijing, UK, Cambridge, the other Cambridge, so I have 2 Cambridges, and here in Palo Alto then, together with Stanford and so on. The title is the same. Of course, you know me. I mean, those who know me, that I can't speak of somebody else prepared slides. So there's been some modifications. So Bob is not responsible of all the things that you see here. So you can only blame me. But the title and the topics are the same. I occasionally say that I feel like I'm an Alice in Wonderland. I had a rather long academic career, decided to go to do work at Nokia. Partly the reason was that I wanted change. People want change occasionally. And I've done a lot of things in there at the university, both in Europe and here in the US, and I decided it's time to do something else. But one of the reasons is also that I was interested in making impact. You know, everybody has this big thing in their mind of making impact in the world. And this Alice in Wonderland feeling really is a result of this opportunity to make an impact. So what I want to do today is want to share a vision. So I'm going to talk some technical stuff, but at the very superficial level. That's not the point here. It's nice occasionally also to be here. I can always use the excuse of being industry, not anymore going to deep science when I'm talking, but more of sharing the vision that I truly believe in, and I would like to other people to join it more and more in these areas. And like we already heard, a lot of this is related with the vision that we have also at Nokia Research as a whole of merging the physical and digital worlds, which is quite natural considering where we come from. But you have to remember that we all get sort of upset and half red here if you start naming us always to be research of a handset company. So we are interested in services. First of all, for example, if you consider my laboratories, we are mostly interested in things which are not handset oriented per se. We just see handsets as an input or distribution platform of a humongous scale. The second thing which makes me tick today is the fact that I argue, sort of a little bit provocatively, that the most interesting distributed computing platform of today and the future is in fact residing in these highly distributed small devices that are being distributed all over the place. And if I've been fortunate enough to look computer science for many, many years, I started when I was sort of young. And so I saw the mainframe era to go to mini computers, going to PCs, going to laptops, going to PDAs, going to then the handsets, the wireless computing, and then to sensors. And every time I've been in this era, I've always seen that each of the new layers here has brought new questions and new challenges. And a lot of the interesting things are happening there. So that's the sort of framework we're talking about. Well, to this audience, it should not be that difficult to see that sensing is the way of grounding a lot of the things you do in the digital world, one way or the other. You sense something, actuation is the other way of grounding. So sensing is input, actuation is output. So today we're going to talk a lot about sensing, which is direct, and actuation, which is somewhat indirect. meaning that it's information that is given to people, and the people are changing their behavior based on that information. A truly direct example of actuation would be robotics, where the sensing and actuation are sort of interplaying with each other directly. Believe me or not, but about 4 years ago, when we started looking at what would be the mission of research, of Nokia research as a whole, you know, all the research we're doing, and try to make this one statement, one sentence that would give us a global and common vision for all of us. We came up with the idea of saying that, okay, looking at where we can make a difference is actually fusing the physical and digital worlds. Today, that vision is much more current than it was, in fact, that time when we were looking at the research we did and the research that is happening. So this is the guideline, and this is the sort of way we see the world. Now, today, of course, what we can sense, we have GPS, we have cameras, accelerometers, light sensors, Bluetooth, so different types of radios, microphones, cell triangulation, meaning that we can look at the position in a different ways than just looking at from purely from the regular GPS perspective. And incoming, meaning that things that we can look at the research but are not yet as widely deployed in the world as the other ones, are near-field communication, a lot of the indoor positioning capabilities, and something with the environmental analysis, meaning that we can sense things which we look outside of, for example, the chemical, outside with the chemical sensors we have, and so on. It was already mentioned that we do collaborative work in one of the most common domains where this type of sensing can be integrated with digital services, and that's traffic. Now, from my perspective, and this is definitely not an official view, this is Henry's view, I always argue that there are three things which touch people globally. I'm always looking at this overall research domain and innovation domain, not only for North America, not only for Europe, but for APAC, Africa, Latin America, North America, and so on. There are three things that touch us all, regardless where you go. One is traffic. If you go anywhere in the world, in the larger areas, you will see that the traffic is an interesting question. One is health, or sort of well-being and health. And then one is entertainment. So traffic is one of the big three for me. And that's also one of the reasons that we here at the Palo Alto lab, we wanted to look what can we do and what we can do by twisting a simple idea of using handsets together then with clever techniques to make a better traffic, well, not only better traffic modeling, but make a better traffic service for people. And we already had this so-called mobile sensory field trial this year, 100 cars driving. We had 100 these N95 standard GPS-enabled devices. We had a lot of eager Berkeley students that like to drive 880. 10 miles of California freeway with the help of some arrangements that we were able to use it. And in the future, what you will see, and what was already referred to this, we will now expand it in scale. To be 10,000 car trial, actually it's 10,000 plus. It depends on, it's hard to estimate how far we're going to go. Coming this fall with Federal Department of Transportation funding, which we are doing jointly now with Berkeley and Navtec and so on. Of course, it helps that Navtec is now part of our Nokia world. Going to this route of 100 to 10,000, please notice that this is exactly what makes me tick. I've been many, many years in academia, and I have all sort of interesting ideas that I'd like to scale. And the challenge always has been that I can never go anywhere beyond a certain amount of things because it's too difficult to do it with the voluntary work or get the things together. And secondly, there's no business structure then that allows me to go into the scale. And I argue that, like you will see in a lot of these experiments, I'm interested in systems that don't scale down. So I'm quite a lot of interested in things where the real value of the service comes from the fact that it's pervasive. We have already examples of such systems. If you look at any search engine, internet search engine, it works only because it's, in fact, big enough so that it's meaningful. If you have only 1,000 documents, a lot of the co-occurrences and interesting things that you do in the model, it wouldn't work. So traffic is one dimension. Now, if you think about then I'm still not very good at this jargon of saying it like use cases and user cases. For me, the way to use a traffic service and how it is integrated to be much more than just a dot on a map can be easily illustrated if you think about somebody driving whatever device, don't care what that is, if it has a GPS and the radio and so on, measuring. There's enough of these things, but interesting enough, not that many. If you look at the results, for example, from the 100-car study, and of course we will know more later on, having an infrastructure that basically is there, because if you have to build this infrastructure, it will be very costly. So this is now, of course, the benefit of having a cellular infrastructure. Having a way of putting things in this mill of data center or a cluster to do this, whatever you want to call it, data mining, data analytics, basic statistical modeling, depends on what your field is. You tend to call the same thing with many names. I always say that this is usually typically to confuse the graduate students. So that's simply. And then you end up in a map. That is one thing. Map can, and looking at analysis of the actual real-time flow gives you some insight, because we are, in fact, also, as humans, extremely good visual processors. But more interestingly, we use the same infrastructure and then combine the information that is crunched here with the information that the device personally knows about you, like your calendar or your appointments, your contacts, other timelines, whatever you have in your email. You can only imagine what the possibilities are. And basically, this device then can utilize this information that comes as an aggregate of several other users there, giving you intelligent and integrated advice. So going way beyond of just showing on the map where there is traffic jams or others, and of course the interesting oscillating behavior you can have this if this would be widely deployed with the delay factors. But basically looking at your calendar and giving the warning, the way that my handset already gives me a warning before the meeting that, hey, it's 15 minutes, you should go, or you should be doing, based on the real-time traffic information. This is a somewhat naive, but a very straightforward application that is useful for us. Location, location, location. Going from traffic, which is a big location going around on the roads, outside there, with long distances, to location where we want to look at things which enable new categories of services which are in micro scale, I guess, with respect to the previous example. We can, of course, think that GPS solves a certain category of problems. But for sure, in fact, if you look at, unfortunately, even in California, we tend to spend a lot of our time indoors, depending on how you work. I prefer to work on the hills or Starbucks, if it's possible, because it's very difficult to do work at your office. It's usually interrupted. Here, it's usually done, at least at the CS, it's done at Euclid, those cafeterias. There are strides to be made both indoors and outdoors, that we know that there's various different types of technologies that allow us to go and use this location information and then to build services. I spent 5 years of my life of seriously, let's say, 50-60% of my time of thinking about location and positioning. That was when I founded a company called Ekahau, which is doing nowadays Wi-Fi positioning. But I was originally interested in GSM positioning by using signal strengths and building statistical models out of it. And I sort of realized at that point of time that location somehow plays a very distinct role in so-called context. People talk about context-based processing, for the reason that it is almost always an enabler. If you don't know the location, a lot of the other context doesn't make any sense. And it's also a good filter to do things. So that's the reason that there's still a lot of challenges and interesting research that can be done and addressed, regardless how many papers you read about the different type of positioning system. Remember, there's our papers. We write these papers, we know, and we get these papers, but scaling up and making them really work is a real challenge. Indoor positioning, I'm not going to spend too much on this one because for this audience, I think it's quite obvious that people have been talking about a long, long time about how do you do the indoor positioning, what sort of services you would enable in shopping malls or offices, stadiums, museums. Sometimes the services are very different. Sometimes the services are information giving. Sometimes the services are more of navigation related. Sometimes the services are even related with advertising. Whatever you like it or not. A lot of the world is evolving around advertising, like the business models of search engine, for example. The interesting thing again is Henry's rule: be lazy, dovetail or piggyback always to an existing infrastructure if you can. If you have to build something, you say that yes, all this is good, but you have to put all these base stations all over all the different Walmarts in the world. You will see the eyes gleaming at the Walmart guys and say, yeah, that's a good suggestion. Thank you very much. We can come back to this interesting topic sometime later. There are many applications. Many of them I've seen hanging around in different visions, papers, academic workshops for 10 years or more. The most recent one, which I think has been underexplored, is related with the social networking. Because I really, truly think that it's nice to do this Facebook stuff and, get all these weird requests to be friends with people that you've never known but have a similar name, or somehow, somewhere in your life you met. But true social network, to me, is mostly related with the people that I communicate daily, but also that I meet in a physical proximity. And location is one of the interesting enablers then for this type of work. I said this so many times that I feel embarrassed that probably there's somebody in the audience who's already heard me saying this. This is the normal disclaimer because somebody's going to ask me about the privacy anyway afterwards. Of course, it's very important for many of these applications, especially in Western world, to make them such a way that people feel comfortable of using them, which typically means that you have to have a privacy-preserving mechanism. Think about, for example, traffic works. People will not be very enthusiastic about the fact that they get a ticket afterwards because somebody has measured, that because their handset was moving so fast on 101, like 75 miles an hour, that evidently you were speeding. So the real innovation, in my opinion, in a lot of the designs that I see nowadays, is that the privacy-preserving features are inbuilt to the mechanism. Whether they are done in such a way that they are not even known at the server side, or whether they are done in such a way that they are partially known on the client side, meaning at the handset side, that's one issue. But basically, that's one of the basic cornerstones of building these things. Now, a typical office scenario, which you usually read, is a rather naive one, so one should in fact think about a little bit further. So the fact that you have a couple of people and you want to have a meeting dynamically, you have the request of doing the nearest available meeting room. The real challenge here is that let's use a lot of intelligence and look at the position of the other parties, look at the position of the different meeting rooms that are available, do dynamic allocation of the meeting rooms per se, and then finally you get the navigation instructions there. So the step of just looking at what's the closest available meeting room is not a very interesting one. The more interesting one is what's the most meaningful way of getting together if you are, for example, at different parts of the campus or different parts of a large office building. I remember I was at AT&T Bell Labs at Homedale. There was 8,000 people in that building. The building was totally symmetric, so if you didn't pay attention to the letters, you ended up being in a wrong quadrant, and you have a half a mile walk to the other end if you had to do that diagonally there. So a lot of these things are meaningful especially in large corporate environments. It might be a little bit surprised that we categorize mobile augmented reality in location. And some sense it is correct to do it this way, but like any clustering, it's somewhat arbitrary. So you could also categorize this to be an interesting challenge area where you use the visual sensing, meaning the camera, to do some queries to the world. This is, in fact, the way that I see it, but that only comes from the restricted fact that I was interested in search engines. So for me, this is just a next step of a search engine. I take a camera picture and I ask, what is this? I want to find out that information. Mobile search experience, to say the least, is cumbersome. And I argue that a lot of the mobile search things, regardless what we search, whether we search for restaurants or whether we search for really keywords on the web, is cumbersome because of the restriction, the physical restrictions we currently have with the device. And the original work of mobile augmented reality started from the simple fact that you think about that you can see the world, you have a camera, and pictures and images let you feed much more information, especially if you combine it with some other sensing information, like location. So the idea of looking something, getting the analysis of the image, and getting back information what you are looking at is a quite natural one, but it has all sort of non-trivial research questions related to that, especially if you want to do it in a wider domain. But it gives us a totally unforeseen opportunities to build location-based services and mobile advertising avenues. Because it's so convenient and so natural that the barrier of doing these queries, whatever you're doing, is much, much lower and much, much easier to understand that people would be excited about this. So think about like looking at that, looks like a opera house in Sydney. So you take a picture, you do some feature extraction. Taking the picture is easy. Doing the feature extraction is difficult, very, very, very difficult. Take use of location. In fact, some other context information too. Notice that if you want to go to the extremes, you do context information of looking at an object by, for example, detecting also the Bluetooth devices that are around you. And you end up having interesting services where you can only see certain things if all your buddies are there. When you were young, you were always playing these, at least young kids, sort of boys were playing these treasure hunting games where you come together and you do these things and you have pieces of map and you come together. So you can build these services also based on more dynamic information than location alone. You go up and down, meaning that up, some of the chaotic features that you have is augmented and done in processed in a way that is not possible in a limited computational capabilities of the device. And then you can have various different types of options which related and associated with that object. To me, this is maybe at the closest of the heart of putting physical world and linking it to a digital world. So I look at something which is physical, but I get the information which is on the digital world attached to that physical thing. And then, of course, then you can build services on top of like buy tickets, do a purchase, and quantity, and so on. All these things that I now mentioned, to me, are obvious. I'm not saying that they are trivial, by far. They are non-trivial typically in ecosystem game, where Nokias of the world are needed. They are non-trivial in some of the research that is needed. Take, for example, the pattern recognition or the feature stuff and all that. In the more universal your recognition situation, the more difficult it is. It is not trivial from the modeling perspective, because building the models, regardless you get the sensing information, is a non-trivial task. But for me, they don't necessarily make me tick that much. So I'm always being ticked by something which goes beyond. So a little bit more interesting challenge is that take this traffic thing and generalize it a little bit. Traffic is looking at the traffic and the cars and routing and navigation. But there are all sort of other things which are in this Henry's wells of interests. Remember, health was one of them. That nowadays we do these different type of epidemic analysis in a very coarse grain. The doctors in the different hospitals in different cities are bookkeeping some of the influenza patients and so on. So you have this. This is the CDC outbreak map, for example. For some example, one can easily imagine, together with the sensors, or even together like we do in India, not even with special sensors, but the doctors doing this with a more fine-grained service in the urban areas like Calcutta, and we can go to a city level and a block level analysis of things. Again, the same way like traffic, this gives a new opportunity for people that are looking at this. The same way like people get excited that you get better data to do a better traffic modeling, this opens a totally new avenues on this. And it's based on the same simple idea that people carry these devices along with you anyway. When we go to the more long-term or sort of longer vision, you talk about also having chemical sensors. But yeah, currently the all sort of chemical sensors tend to be very, very sensitive to, for example, somebody breathing heavily to the device, and the measurement goes totally off. My favorite is weather, and it's very, of course, unfortunately current example, just at this moment. Again, I always wondered why, and I understand there's a commercial region, but these weather stations here, particularly in the US, tend to be at the airports. So if you go to Weather Channel or whatever, you see this weather. And, well, besides me, who's living typically on 65H on British Airways on the upper deck, very few of us live at the airport. So again, the fine granularity, instead of having this nice picture where you say that San Diego is 78, so you should be able to go to much more detailed contour areas. I think Bay Area is among the most interesting test beds we've ever had. When I was at NASA, there was a discussion that is 186 microclimates between San Francisco and San Jose. And if you drive there, we all know this different things. So in Palo Alto, for example, the Palo Alto forecast doesn't forecast very well where I live. It's usually underestimating the temperatures. So again, the same idea, but now applied to weather. So what we are doing is we're working now with AccuWeather to start building, together with Navtec, a integrated services then that can be on top of the traffic. Now, correlating traffic information and weather is also quite an interesting thing. And it also answers the question, which I think is one of the most challenging abstract questions we have. What type of latent, non-visible things you can infer from observables when you have enough data and you can correlate these things? And that's exciting. In China, we are now looking the similar thing than would be possible here in Bay Area. These are, in fact, the seismic, the map of the seismic sensors around the Bay Area, which is one of the densest probably in the world, having these for obvious reasons. Again, the seismic sensors are fine, and they give you good information. But they give you only information which indirectly then implies something. So if there's a high seismic peak, then you might infer that there's something bad happening to the houses that happen to be there. But this idea of using the users, so-called, we call it citizen journalism for lack of a better name, that can attach information to that event, time tagged, gives a much more richer mashup on things. Having with all the problems of noisy data, having all the problems of people, taking things. Well, I don't think anybody's faking very much if there's an earthquake. I think people are sort of motivated with some other things at that point of time. But for example, in China, now with the Sichuan several earthquakes, a lot of these type of services are now being explored or studied, so that the future earthquake situation where you have easily 1 million people without home, like 1.2 million, I guess, is in the first, the larger one there. There's a tremendous need of getting information fast. And then the last one, I'm going to just skip, of course, the obvious thing. If you're a great football fan, in these big stadiums or big concerts tend to be places where you want to find out where's the gate where there's least line, where can I buy things, where the sort of crowd flow, which is not car flow, but it's pedestrian flow, is as interesting to model in a lot of the places as the car. The challenges are real. I already mentioned privacy. Privacy. A lot of these things, the better they are, unless they are handled in a proper way, the more intrusive they are. Second thing, which is even more important to me, is that, and this is the real challenge again of the collaboration that I'm encouraging, is the scalability. We all know that there are a lot of interesting modeling techniques, there are a lot of interesting things that we can build, but when you scale them to 100 million to 1 billion, for sure they don't help. And this is fundamental, by the way, it doesn't mean that this simply we just wait that the computers get a little bit faster and then we get the event. It is, in fact, fundamentally so that regardless how good, for example, a complex stochastic modeling system you have, the models computationally might be totally prohibitive, and you need to go to approximation. I know this for sure from the modeling work we did with search engines, going to hundreds of millions of documents. So this is also a theoretical problem. It's not only an engineering problem. I guess this is my point. Interestingly enough, one thing which is a little bit boring, I tried to avoid it in my life since my first touch in some of the 80s, is standards. But certain things don't work without standards. Whether the standards are de facto or whether they are, standards which have been agreed upon, like some sensor output from the cars, that doesn't matter. But some kind of standards have to happen. If you look at the standard plugins on Facebook or any other big platform for social networking, this is exactly a type of standards that also exists. It's just a different standard than you have in telecom, where certain things are agreed in a very tiring process. I had a very nice slide, which I don't remember anymore, but it was a comparison of, because I couldn't find it on the stick, I was supposed to add it here, about the scaling. But the interesting thing is now that I like to jump in different scales, and I argue that the scale that we now have when we are looking at the services is totally unparalleled in human history. This doesn't now show well there, unfortunately, but this little bit lighter dots are basically representing areas where you have like the intensity of electricity distribution on the world. So you can see there in Europe and East Coast and West Coast and sort of this. If you overlay to that the internet access of the world, you already see that there are more dots there, which is an interesting thing if you sort of superficially think about it. You have internet somewhere where there is no electricity. Network, notice. If you compare that to an overlay of cellular coverage in the world, this is the cellular coverage on the world, you again see an interesting trend here. So now, this means that we have in the world, we have areas which have cellular coverage, but we do not have electricity there, which is obvious, of course. If you think about these guys have batteries, and the ways that they are used in Africa, for example, for intermittent use and so on. But the tremendous opportunities that this pervasiveness of the devices gives us is something that should stop us and let us think a little bit. So currently there's 3.3 billion subscriptions worldwide is going to be more than estimated more than 4.5 or 5 billion by 2010. Even us, as a single company, we have already sold more than 1 billion devices. 80% of the world's population has coverage. This is really interesting, like in places like in Africa. The ratio between PC to a cell phone, even a cell phone access, even if it's not your own, is something like 8,000 to 1 or so. There's 220 countries and territories that have GSM networks alone, which is only one standard. There's 1.2 million GSM subscribers added every day. And another number that I usually like very much is that current speed of delivering devices in Nokia is 17 per second. So when we reach about 35, you can hear Nokia because it's 35 hertz. So these volumes, and if you look at where the volumes will go, makes you think. 64% currently are in emerging markets, and that's going, the percentage is going up fast. Means that we have the question of how do we serve the next 1 billion customers, which is not going to be here in North America or in Europe, but will be in Africa, APAC, partially Latin America. And what sort of special things we need to think about. And this is another thing, like I said, I left academia, came here, because I had this great enthusiasm of looking at the growth market, so I'm responsible for the growth market research in Nokia. I have a lab in Beijing, I have a team in India, we have a team in Africa, and I'm mostly interested in looking at the different questions that come up. So I decided that maybe I just end this talk of telling of something which I believe is a great thing that is happening now, and I would think that all of us should be involved in this. The distribution, the fact of the cellular coverage, and the fact of the ingenious ways that people can use these devices because they are communication devices, and then they build their own services on them. For us, some of them look very preliminary, very crude, but they are making a true difference there because there is no alternative. So there are new payment systems. Minutes, like in Africa, are considered to be cash. So you upload minutes. You make a payment by uploading somebody's account with minutes. And minutes translate directly to a currency because it's useful that you can make a call and ask from markets on a village which is 10 miles away or 20 miles away whether it's meaningful to go and sell some stuff there, or if you're a fisherman on a boat and you want to go. You must have read of some of these examples. I like this. This is a good example of the ingenuity of what I call the growth markets. Nobody here thinks about minutes as a trading thing. Maybe the teenagers occasionally might think about that. But this is a totally obvious and natural thing. There's all sort of other things that we see as a phenomenon, and a lot of the work here at Berkeley School of Information that looks at this repatriation of both expertise and funds, foreign workers sending earnings to families back home, create new type of systems where accessibility at the other end is not only at the simple bank, which exists in very far away or maybe in the major cities, but also to the individual level at the villages. Microfinancing, you must know about Grameen Foundation or Kiva.org, where you just make loans, these micro loans for people, and they are managed by these organizations, and then you may get back. But this enables new type of finance, new type of business in these markets, where $200 can make a difference to start a business. One of the things that you might find interesting is that the Cambridge lab, my US Cambridge lab, is doing work which is called Mosoko in Kenya. Mosoko is a Craigslist in Kenya, which is based on the simple idea that you make this what my daughters would call a one-timer, meaning that you make a phone call which rings only once to the service, and you stop. So there's no payment involved. You're not making a call. They call you back to the number, and then there's a voice, currently a voice-directed menu where you have a Craigslist of, housing, you're selling whatever, the different types of things. It's working, and we are looking at the SMS-based system. Where the important point here is not so much this crude service, but notice the idea that you can do this so that it's free for the people, the same way like people use here now from the internet are using this Craigslist, and you're not paying any kind of subscription fee or anything. You would look at who on earth would like to go through the menus on this by voice. Sure. But if you think about it, you have no alternative. You sure will do it. So the question is that you are also have to look at these questions in a very different way. And what is meaningful for the people in the growth markets is totally different, occasionally, how we view it. The door is open for new models of endurance technologies. I mean, all these fancy things which we have great, whether they are whatever handsets we have, if we run out of the energy and there is no energy, remember the electricity chart there? They are totally useless. So there are these endurance technologies, new charging technologies, convenience faster. In the nanoscience research that the Cambridge UK lab is doing, we are looking at a lot of the different types of battery charging techniques and battery techniques, which are beyond 10 to 100 times of the current batteries. There's new way to protect the gear. The conditions are much worse. They're definitely not your favorite device which opens. In fact, the flip-flops are particularly bad in this, because if you get the connections in the opening, the device will get kludged. But more complexity can be seen in applications where you understand the cultural differences of things. So something which we call loosely structured navigation, which is beyond the map world. In fact, there's a lot of people in India have no clue of the Western maps. We, in fact, learned this also the hard way, that we have Nokia maps available, and I was looking at how is it so unpopular in India, and there are various different reasons for it. One of the reasons is that many of the people have no clue what this map means. I mean, you look at the map, and yeah, sure. 1 out of 5 people are illiterate anyway. So we build these literacy-neutral systems. We want to move past language-dependent UIs, but we also want to do like navigations which are beyond the mapped world, the places where there are no maps, or bases that the people only can understand landmarks. And you look at the landmark-based navigation, a totally different paradigm from the Nokia maps or AT&T maps or whatever maps. What are the challenges? The challenge for us, looking at the research and also from the business perspective, what value will emerge from these multisensory connected devices? Clearly, we can build a lot of different things with them. But what is the value of it? I mean, engineers can build arbitrary amount of different things, and geeks like me can even use them. But for a lot of the normal people, it doesn't make any difference. So what's the value? We clearly do have challenges in the scale. How do we network hundreds of millions of users in markets like India or China? What's the needed security? What is the need to make these things that we build, like I said, not only privacy preserving, but also secure? That if you do payment, you don't particularly like that, if you lose your device, then your bank account is immediately empty, whether it's minutes or whether it's currency, it doesn't make any difference. What commercial ventures can be formed around these opportunities? And how can we enable the next 1 billion to participate in the global marketplace? A lot of the things I now described is happening locally, and that's the way to go. These things come up from bottom up. But if you want to have like a global eBay, also and there's not only Craigslist, but eBay in Africa, this is a question. Now for us, what we do is that every year we make a map. I mean, what we call chief strategists, which typically are the lab directors, some senior fellows and others. We look at the future and the technologies in different areas. And it's always 7 years ahead. So this year it was, we call it Agenda 2000 something. Agenda 2015. And we identify areas where we want to do research in the next 7 years. What are the areas we believe that will make a difference and what are interesting? And of course, we refine these things every year. Sometimes some things drop, some things come up. And of course, not all the research is going in here. In a research, you always need something which is beyond any map, because the truly disruptive ideas usually come from there. But these are the areas. Notice that we put that currently we put a lot of emphasis on user context modeling, human interface. Physically personal devices mean devices which actually the form factors and the physical thing forms based on the personal use of the thing, not only the software. Internet of Things, which is the sensor world, the addressable sensor world, scalable service platforms, dynamic wireless, mostly concerning cognitive radio or software-defined radio stuff. Mixed reality is like related with the thing that I was showing you about the mobile augmented reality, but only also the other side where you bring physical things to the second lives of the world. And creativity, which is not a very good name, but it means the user participation. So I really invite you all to look at these things, work together with us. We, in the spirit of open innovation, in these areas, these are the areas we find exciting. These are the areas we think that there's going to be impact, and these are the areas we are willing to invest in research, both internally and externally. So this is a good time to end, and almost on time. So thanks.
So we will have time for some questions, but before that, I would like to give you the honorary plaque of the lectures.
Okay,
now, this one is in the name of Bob.
Okay, so I will give it to Bob.
But,
So that's okay.
maybe you
That's
guys
fine.
can share it. So
I'm fine. I have some of these, so I will give to Bob this. He probably appreciates this a lot, and he's.
So we have time for some questions from the audience, and if there are some internet questions, I'll read them as well. And we have a person with mics there.
Hi there. Well, I'm looking at your talk and thinking in terms of mesh granularity and degree of granularity in future realms. And so, do you see a realm in which things like smart dust or RFID tags actually become like another layer added to the layers you're already talking about as a kind of a bidirectional sensory system?
Yes and no. This is a typical answer on this. Yes, of course. I feel that the sensors already are at the the outmost layer of Internet. They're just not very well integrated with the Internet. And one of the things that I've seen is useful is that you use larger devices like handhelds to connect and act as gateways, because they can not only be used as sensors themselves, but they can help because they are radio devices to connect to these short-range radio devices. Yes, I envision deeply, and wireless sensor networks has been my interest for a long time, I deeply believe that in the long run we will have. RFID is sort of rather dull thing, but it's of course going to be prevailing in logistics and other things. Yes.
But it's very cheap and it's very ubiquitous, and that was
yeah,
kind of
I know.
the point.
It has reached the level of maturity after many, many years. So yes, sure.
Do you have any other questions? Okay.
Yeah, we have so little oxygen probably in here that if you can think anymore, that's pretty good. I'm exhausted already from.
Can you comment a little bit about indoor localization?
Yes.
In the absence of wireless LANs or other infrastructures, what are some techniques you have in mind?
If there's no radio, I mean, no radio carrier, whatever, Wi-Fi or things, then you have to build some kind of, one approach is to build some cheap infrastructure. There's a lot of work that is done on different type of beacons that you can put in there. Now, now excluding this is a very weird situation because most of your handsets work indoors. I mean, we can make the call, so there is radio always. So this way, this is a pretty hypothetical situation in a lot of the cases. But there's an answer to that which is theoretically more interesting. You can do localization by images. So you do not need the carrier radio to do that. You can do it by imaging and building maps, for example, which are visual maps of the area. So I truly believe in these hybrids. So it's like assisted GPS. You can do so much with GPS, but when your GPS is not available, you do something else. I believe in this mobile augmented reality. For example, you use the accelerometer for orientation and maybe some localization, but you can also do image-based location. So So I think there's a lot of rich area to look at. But it's hard to find nowadays areas unless you go to special environments like mines or other places where you don't have radio already available somehow.
And radio only, the localization is trivial?
No, it's not trivial, but it's a good basis of it. It's non-trivial, for example, for signal-based methods if you only hear one radio station, one base station. It's hard to do. First of all, triangulation is definitely impossible, but also with the single strength-based thing is pretty bad. If you only hear this one thing, you hear the one thing, and you can do.
Nokia, as you kind of alluded to, is becoming more of a services company. How do you see yourself competing with some of the new players in the field? That Symbian obviously has one of the largest OSs out there, but the application and the innovation that's happening on some of the other frameworks, maybe the Apple SDK or OSs that aren't even out yet, like Android. How do you see Nokia starting to compete on this level of developing more and more applications and filling the void?
It's a very good question, meaning that that's an ecosystem question of what I call open innovation. I mean, the open innovation to me means, regardless of my namesake here who launched the terminology, to me means that you allow, you enable enough platforms that people can innovate on and use their creativity to do this. Now, the question of an operating system or the sort of certain type of a level of enablers like Symbian, Linux, Windows Mobile or Android is an interesting one. I think each one of them has different things. You must understand that there are reasons why we will make Symbian to be open source for obvious reasons. But the game is played in a very complex way. And it's almost that economists, if they would look at it, I would say that this is like a VHS beta type of a game. It's going to be difficult. Currently, the Symbian programmer platform is, in my opinion, unnecessarily complex for the developers to do with respect to some others. On the other hand, Apple keeps very close touch on who can develop on things. So it is not a truly open environment either. So the game is played very many different ways. I mean, if I knew the answer, I'd probably be very popular at the company. So this for sure.
I have sort of a follow-up to the previous question. As Nokia gets more into services, you'll be competing with your own customer, who are the actual service providers. We call them service providers. Those are your customers. So how do you avoid getting into trouble? They have a little bit more power over the whole system than you do because they own the radio frequencies. How do you avoid competing with your own customers?
Yeah, I agree. I also thought this to be very differently until very recently when I learned how this is done. Now, first of all, let's take a not only North America perspective. This is a very particular market with the AT&T and your carriers evolved to be very strong in dictating what is going on. This doesn't hold anywhere else in the world except in North America. It's good and bad for you guys. Bad in the sense that the lock-ins that you have with the services are then dictated by your carrier. So that's a challenge. On the other hand, the good side of it is that it's very integrated and it's very easy for you to, you just get the AT&T whatever stuff, and if it works, it works. And that's right. Now, competing with your customers, let's say, I learned now that a lot of the ways that we do the music service and others, we actually partner with them. We do revenue sharing. Everybody wins. So it's only in the core functionalities where if the carrier wants to keep it to be a solely exclusive property that there will be a clash on that. So, and this is particularly true in APAC. And it's also true with the carriers like Vodafone, which are very large in the world, that we have partnering with them in music service, in a lot of the new entertainment services, which as a simple-minded view would directly be conflicting with something which they do. And what you might ask, what's the benefit from the carrier perspective? Carriers have the same problem that we do have. Innovation is expensive. It is hard to do certain things. yes, they have the control of the radio, but they do not have the control of the actual devices and manufacturing of the devices. So you have to trade. This is like a game of diplomacy, if ever anybody played this. Today we are friends and we go against somebody else, and tomorrow we might be enemies in some other field. So it's a good question, because I also originally thought that this is going to be a real challenge. Now I learned, in fact, that this is not the challenge. We have other challenges, but this doesn't seem to be the challenge.
Do we have any more? Oh.
How about wireless video? Do you think that's an oxymoron, or is it ever going to take off, or at least in a broadcast sense, like TV?
Oh, wireless video? No, I mean, if you go to Korea, hey, come on, the guys look at TV, so why not they look at wireless video? So I mean,
yeah, but has it taken off?
The video, in APAC, the TV, tremendously. For me, this means that the video will just follow. I mean, it's a bandwidth question. There's all sort of other things. Some of these things are very difficult to understand. I think that understanding is occasionally cultural, and the cultural doesn't necessarily mean geographical difference. If I look at my daughters, certain things are very much consumed, which I would not feel at all proper or sort of necessary. So it's hard to predict, but to me, everything that we see that people use on a regular internet, on lines, will eventually be on a wireless anyway, because people are just used to using it and they just do it. But as long as it's too cumbersome, they will not go with it.
But I think the form factor is one. I mean, by definition, this is something that's going to fit in your pocket and not burn a hole either. But can you really watch video on something such a small screen?
The interesting question that we work now with the entertainment industry is you can also, first of all, design videos and games which are meant to be a little bit different form factor. Secondly, form factor and form factor. If you look at the tablet size, it's almost sort of usable already. If you go to the projector, energy projector to somewhere else, it's even more usable. So form factor should not be looked at too closely. This is the second thing which I find rather remarkable, that clever people get so stuck with thinking that the handset is always like it is, and the display is like this and whatever. Of course, it's an energy question. It's a technology question. But these things, for example, foldable displays that we do at the nanoscience lab, that allow you to have a foldable display of this size, and it's transparent, semi-transparent. You can go through it. It's going to change a lot of these arguments. But it will be longer in the future than if you ask next year. I would say that no, it will not fly.
Well, I'd like to thank our speaker again for covering today. Thank you very much.
Thank you.